So in this video we have integral 1 over 9x squared minus 16 dx. And first thing I notice here is that I've got squared in the denominator and a constant in the numerator, so there's no u substitution that's going to work for me. I'm thinking, okay, I see difference of squares. Maybe it's a trig substitution, but I don't see a square root, so it's not really going to work out for me. But then I think, all right, this thing is a difference of squares. I can factor the denominator, and it absolutely factors. Square root of 9 squared is 3x. Square root of 16 is 4. So it's going to factor to 3x plus 4, 3x minus 4 dx. And so the question just becomes, how am I going to find the number that goes up in each part here? Okay, so once I get that number for each factor, then I'm good to go. All right, so let's break this down into an algebra problem. And so I have 1 over 3x plus 4 times 3x minus 4 equals a over 3x plus 4 plus b over 3x minus 4. Now, why did I use a and b here? Both of these are linear factors, and so I have constant numbers up in the numerator. Remember, it's to use partial fractions, the numerator degree needs to be less than the denominator degree, okay? So I need to figure out what to multiply by to start solving this. I'm going to multiply by the common denominator, least common denominator. I see a 3x plus 4 and a 3x minus 4, and it has both of them on this side, so I'm going to multiply through by 3x plus 4 times 3x minus 4 on all of this here. And so if I multiply everything through, what am I going to see happen? Okay, distribute this to each term in here. Get that there, and that there. Can't write it out that quickly, sorry. Pause the video and then write it up and then go from there. So I'm just distributing this through to each piece in my equation. So when I do that, I see some cancellation going on. 3x plus 4 cancels 3x plus 4, 3x minus 4, 3x minus 4. So I'm left with 1 equals 3x plus 4 cancels the 3x plus 4, and 3x minus 4 cancels 3x minus 4 there. So I have a times 3x minus 4 plus b times 3x plus 4. Okay, so at this point we can multiply it out, or we can plug in x values that cleverly work. I'm just going to plug in values. X equals, well, what would make this term go away? Well, that would need to be equal to 0, right? Well, 3x minus 4 equals 0 when x is equal to 4 over 3. Okay, so 4 over 3 produces an x equal to 0. Or, I mean, this term going away, right? And that's what we're trying to do. And so I get 1 equals a times, if I plug in 4 over 3 here, I'm going to get 0. And if I plug in 4 over 3 here, yeah, okay. So this is going to be 1 equals 0 plus, and then this is going to, 3's are going to cancel there, so that's 4 plus 4 is 8, so that's 8b. So that tells me that b is equal to 1 over 8. Okay. Right. And then to get rid of this other piece here, I want to see what could I plug in for x to get that equal to 0. Well, if you do the algebra like we did over here, then you're going to get x equals negative 4 over 3. Okay, so x equals negative 4 over 3 gets me 1 equals a, and then 3 times negative 4 over 3 minus 4. Oh, sorry. Put one too many parentheses there. And then plus b, and then 3 times negative 4 over 3, plug in for x, plus 4 there. And so this gets me 1 equals negative 4 make negative 8a, plus, and then b times 0. And so a is equal to negative 1/8. So I have 1/8 and negative 1/8 for my a and b there. So my integral, the term that has the 3x plus 4 factor, that's my a term. A is negative 1/8. So negative 1/8. And then the b term is the one that has the x minus, or 3x minus 4 factor, and that's positive 1/8. Okay? So I'm going to take this, copy it, move it down. We're going to integrate this now that we've figured out what those coefficients are. So a whole thing about the partial fractions is just so that we can get these two numbers here. Okay? So once we get those two numbers, now we can start putting things together. So let's try it out, see if we can get it to work. Let's do u substitution. U equal 3x plus 4. Du is equal to 3 dx. Well, I don't see a 3 dx, but I see a dx, so I'm going to divide both sides by 3. So I have 1/3 du. And then here I've got negative 1/8. So I have a 1/3 du and a negative 1/8. Okay, and then in the denominator, I just replace that with u. And then here I have 1/8, and then u equal 3x minus 4 gets me a du of 3 dx. So same thing, 1/3 du equals dx. So 1/3 du going on there all over u. And so I'm going to pull out the coefficients here. So negative 1 over 24 integral 1 over u du plus 1 over 24 integral 1 over u du. Where did the 1 over 24 come from? 1/8 times 1/3. Okay? And so whenever I integrate this, this is a rule. Integral of 1 over u du is ln absolute value of u. So this is negative 24 ln absolute value of u. And I should have used a different variable for each of these because u is not the same for each of these problems. U is 3x minus 4 here, and u is 3x plus 4 there. So as long as you keep track with that, I'm not too big of a stickler on that, but technically I should have used a v there, but whatever. All right, so ln absolute value 3x plus 4, and then plus 1 over 24 ln absolute value 3x minus 4 plus c. Okay? And so if you wanted to combine this, you could. I'm just going to leave this right here, and for the more, by the book student might see if they could simplify this algebraically. All right, let's move on to another one. Integral 2x squared minus 3x plus 1 over x cubed minus 4x dx. And so first thing I do here is I'll look at it and say, can I make this any easier? Well, a U substitution, if I notice that the denominator is 1 greater than the numerator, so it could be the case that a U substitution works, but U equal x cubed minus 4x. If I do du, I get 3x squared minus 4. But there's no way to make this go away with that right there, okay? So I'm kind of stuck. My U substitution falls apart. All right, so U substitution is not going to work. Now I need to think partial fractions because, lo and behold, the denominator factors. I can pull an x out. I have x squared minus 4. But then x squared minus 4 factors to x minus 2, x plus 2. It's a difference of squares. So I'm going to factor this, and I'm going to be left with 3 things. I have something over x. I have something over x minus 2, another linear factor. And the last one, I have something over x plus 2, the last linear factor. Okay? So those 3 linear factors, 1, 2, 3. And now I need to figure out what goes in A, B, and C. So this is the partial fractions technique here. I have 2x squared minus 3x plus 1 over x times x minus 2 times x plus 2 equals A over x plus B over x minus 2 plus C over x plus 2. Okay? So I'm going to multiply everything out. Multiply everything by the denominator here. The common denominator, least common denominator multiplied through. Well, if I do that, I get 2x squared minus 3x plus 1 equals, well, let's see what would happen here if I multiplied this through here with that, and then multiply it again. This through here with that, and then here, multiply it through there. Kind of ran out of room a little bit. Sorry, it's a little sloppy. Okay. And so what cancels? Well, the x's cancel there. The x minus 2's cancel here. And then the x plus 2's cancel there. So I can simplify this a little bit. I get 2x squared minus 3x plus 1 equals x minus 2, x plus 2a plus x times x plus 2b plus x times x minus 2c. Okay? So here, once again, I think that it's easier if you just pick x values to plug in that make other terms 0, but if you want to do something else, you do something else. All right? So what do I mean by that? Well, I have factors of x, x minus 2, and x plus 2. If I plug in 0, that's going to make a term go away. If I plug in a 2, that'll make term go away. And if I plug in a negative 2, that'll make terms go away. So let's start with x equal to 0, because 0 is like the easiest one to plug in. So if I plug in 0 here, this gets me 0, minus 0 plus 1. So 2 times 0 squared minus 3 times 0 plus 1. So that's just 1, right? And then if I plug in 0 here, I have 0 minus 2, 0 plus 2a. And so that's going to be negative 2 plus 2, that's negative 4a. And then 0 times 0 plus 2b. And if I do that, that's going to be 0 times anything. That's going to get me 0, so who cares? And this last one, 0 times 0 minus 2 times c. Well, that 0 again is going to make all this go to 0, so who cares? So this tells me that a is equal to negative 1/4. So the term that has the x under it has a negative 1/4 coefficient there, so this needs to be changed to negative 1/4. All right. Next one, x equal negative 2. If I plug a negative 2 in, what do I get? I get 2 times negative 2 squared minus 3 times negative 2 plus 1. That's whenever I plug in over here. What is that going to... That's 8 plus 6 plus 1. That's 15. Okay, and then negative 2 minus 2, negative 2 plus 2. Well, negative 2 and plus 2 get me 0, so I don't care about that one. That's going away, the a term. Negative 2 and negative 2 plus 2b, that gets me 0 again, so that second one's going to be 0. The last one, negative 2 and then negative 2, negative 2. So that's negative 4 and a negative 2. That's positive 8c, so 8c. So that means c is 15 over 8 if I solve for c there. So c is the one with the x plus 2, so 15 over 8. So 15 over 8 goes in there. The last one, x equal to 2, what's that going to be? Oh, man. All right, so 2 times 2 squared minus 3 times 2 plus 1. So that's 8 minus 6, that's 2 plus 1, that's 3. So 3 equals... Okay, if I plug a 2 in here, that's going to make this go to 0. So that's going away. If I plug a 2 in here and a 2 in there, that's 2 times 4 is 8, so that's 8b. And then if I plug a 2 in here and a 2 minus 2, that gives me 0, so that's going away. Okay? So this tells me that b is equal to 3 over 8. So this last one here is 3 over 8. Yikes. Okay, so let me try to clean that up a little bit. So when I substitute those values in, here's what I see, my constants. One thing I like to do, since it's just a constant, you can pull that out of the integrand and just put it in front of the integral here. 1 over x dx plus 3 over 8, 1 over x minus 2 dx plus 15 over 8, 1 over x plus 2 dx. Okay? So now I'm going to do, I'm just going to integrate this one because that's ln absolute value x. So put the 1/4 for your constant out there. This one's an easy u-sub. You're going to do so many of these that you're just going to be able to say, oh, that I see that u-sub is simple. It's du is dx, so I don't have to do any trickery there. So this actually does be ln of whatever was in the denominator here, since this coefficient here is a 1, okay? You start to notice if that was a number there, like if this was like a 3, then you end up picking up like a 1/3 factor to take care of that differential going on. Okay, so absolute value x minus 2 there in my natural log, and then the last one, 15 over 8, and then integral of 1 over x plus 2 is the natural log, absolute value x plus 2 here, plus c. And like, same thing here, you could do a u-sub if you're still not comfortable with that, and du is dx. And when you follow through with the u-sub, you're integrating 1 over u du, which you know to be ln absolute value u, but u is x plus 2. Okay, just like that's x plus or minus 2. So here you've got your answer. And if you wanted to get crazy and simplify, you could. For reference, you could have, to check it, your answer would look like this. Not saying that you have to do this, just saying that it is possible. All right. Let's try another one. We'll do one more for this video. Integral x squared minus x plus 9 over x squared plus 9 squared. So threw this one in because I wanted you to see an irreducible and what to do with an irreducible. Okay. So what do I mean by that? Well, for starters, we need to know how to set this up. Okay, we need to know how to set this up in partial fraction form. So I have x squared minus x plus 9 over x squared plus 9 quantity squared. So I have two factors of x squared plus 9. And x squared plus 9 is irreducible, meaning it's impossible to factor. You think about it, it's a parabola shifted up 9 units. So there's no place where it crosses the x-axis, therefore it's no real factors. And so since it's a power of 2 on those quadratic irreducibles, we've got to build up. So what do I mean by build up? I mean I have an x squared plus 9 factor, but I also have an x squared plus 9 quantity squared factor. Okay? Since it's irreducible quadratic, I need a linear numerator. Okay, ax plus b. Same with this one, irreducible quadratic. I need a linear, 1 degree less than the denominator, right? Factor. And I don't know why I wrote ax plus b. I need to have a different letter, so because they could be different numbers, cx plus d going on there. Okay? To solve, I'm going to multiply through by x squared plus 9 squared, because that's the common denominator. When I do that, those cancel for that piece, and then here one of them cancels, and then here both of them cancel. So x squared minus x plus 9 equals ax plus b times x squared plus 9, and then plus cx plus d. Like I said, this would cancel with this right here, and then this right here cancels with that right there too. And then only one of those cancels with one of those there. That's why we have the one left over right there to multiply through, if you so choose to multiply through. I actually am going to multiply all this out for this particular problem because it's not apparent to me what value I could plug in to make terms go away, what number. So I'm gonna plug in, or I'm gonna distribute this out and see if we can't do it the polynomial way, where we make the coefficients line up. So FOIL this, double distribute, you get ax cubed plus 9ax plus bx squared plus 9b plus cx plus d. I'm just copying those over there. And I'm going to have a cube term, so a and then x cubed. I'm going to have a squared term plus b x squared. I'm going to have a linear term, 9a plus c x, and I'm going to have a constant, 9b plus d. 9b plus d. Okay? So this is equal to 1x squared minus 1x plus 9. I'm putting an emphasis in writing these coefficients out, because once again, I want to make sure that they line up. The x squared terms need to line up with the x squared terms. The linear terms need to line up with the linear terms. The constants need to equal the constants. And what else do I have going on here? It looks like I've got a cubic, but I have no cubic over here. But technically, you could write 0x cubed. Okay, so just because it's not there doesn't mean you can't have it. So what do I know off the bat? I know that 0 equals a. Okay, so that's easy. What about the squared terms? 1 equals b. Okay, that's not too bad. And then I have -1 equals 9a plus c. But what do I know? A is equal to 0, so that means that this is equal to c. So -1 equals c. Man, we are just getting through this really quickly, right? See how sometimes one method is easier than the other. So don't be afraid to adjust your method. And the last one, 9 equals 9b plus d. B is 1, so 9 times 1. And so that means 9 equals 9 plus d. The only way that's true, to add something to 9 to get 9, well, that means d needs to be 0. So 0 equals d. So a is 0, b is 1, c is -1, and d is 0. Okay, so we go up, and I'm going to put 0x plus 1, and then -1x plus 0. So what does that mean? This is 1 over x squared plus 9 minus x over x squared plus 9 integrated dx. Wow, right? But we got it. So now I'm going to try to find this integral. First thing I'm going to do is I'm going to split this up into two integrals. Integral 1 over x squared plus 9 dx, then minus integral x over x squared plus 9 dx. Okay, so divide and conquer here. All right, this should be looking familiar. This one should look like arctangent to you. The only difference is this is not a 1, it's a 9. But if you do a little bit of algebra, you can turn it into a 1. What I'm going to do is I'm going to factor a 9 out here. So I have 1/9 factored out, and that leaves me x squared over 9 plus 1 dx. Okay, and then I'm going to put the 9 inside the squared part. So I'm going to pull the 1/9 out. And then what do I mean by this? I'm going to have x over 3 inside all squared. You see how I put the 9 inside the squared part? So it's 3 squared is still 9. Okay? So now I can make a u substitution. U equals x over 3. Du is 1/3 dx. So dx is equal to 3 du. So this becomes what? 1/9 integral 1 over u squared plus 1, and then 3 du. The 3 can come out front. Okay. And so 3 over 9 is 1/3. And the integral here, this is the rule, tangent inverse u plus c. And so it's 1/3 arctangent of x over 3 plus c for this first part here. Okay, so we got the first part done. Check. Now let's do the second part. The second part here, this looks like the power in the numerator is 1 less than the denominator, so I'm thinking u sub. U equals x squared plus 9, du is 2x dx. I don't have a 2x dx, but I have an x dx, so I'm going to divide by 2 on both sides. So 1/2 du is x dx. Okay. And that's going to give me negative integral 1 over u, and then 1/2 du. I can pull the 1/2 out front. Pull the 1/2 out front there. And so this is negative 1/2 ln absolute value u plus c for that part. And so u is x squared plus 9, so it's negative 1/2 ln absolute value x squared plus 9, okay, plus c. So combining these two together, I get 1/3 arctangent x over 3 minus 1/2 ln absolute value x squared plus 9 plus c. Now, technically, you could drop the absolute value here and just have parentheses. Why? Because x squared plus 9 is never going to be negative. We don't have to worry about that being negative or 0 for real numbers. But I'm just going to leave it there. But if you did see a homework problem where they dropped an absolute value, then you would know why they dropped that absolute value there. Okay? So a lot going on there. But it's definitely doable, okay? Wait a second. Oh my gosh, I'm so sorry, people. I messed up this second part right here. Why did I mess it up? This is not the denominator. The denominator is not that. It's actually squared, right? We squared it. Okay, so this is all squared. Okay, that's only going to change this problem slightly. Sorry about that. And so that changes it a little bit. So instead of it just being u, it's u squared. And so this is where this is where the problem is changed a little bit. This is what happens whenever you just go off the cuff. All right, so if I do this here, this is actually negative 1/2 integral u to the negative 2 du. What about negative 2? Integrate. I can use the power rule, add 1 to it, u to the negative 1, divide by it, divide by negative 1. So the negatives cancel. That gives me a positive 1/2, and then 1 over u. Bless me. All right, and so this is 1 over 2 parentheses x squared plus 9. Okay. All right, so I mean, I guess that's even a little bit easier than what we did here. Okay, so then plus 1 over 2, and then x squared plus 9, close parentheses there. Sorry about that little bit of confusion. If you're like, well, you know, I was thinking that power increased. You were absolutely right. I made a goofball. Sorry about that. I guess I could put like a -1 on my ticker. All right, guys. Y'all, if you got any questions, let me know.